Before we get into solving inequalities, we just want to understand some of the properties that we can use to be able to solve inequalities. It's very similar to properties of equalities. We're just going to look at four of these: addition, subtraction, multiplication, and division. Starting with the addition one, I just want to look at an example with numbers. So like, for example, you know the following statement to be true, right? That 8 is greater than -3. So if you were to add something to both sides of this inequality, so like if I were to add, how about 2 to both sides, then the resulting inequality you would come up with is that 10 is greater than -1. And so you started with a true inequality, and then you added something to both sides, and the inequality you got is still also true. And so it just turns out that that always is going to work when you add the same thing to both sides of an inequality that's already true. So basically, more generally, is if you have that x and y are compared somehow. So I'll just put a box, and that box could either be a less than symbol, or a less than or equal to, a greater than, or a greater than or equal to, whatever symbol you're going to use, but just keep it the same. So if you have that comparison, then by adding the same thing to both sides, so if I add, let's say, z to both sides, then that comparison is still going to hold. So if it was less than there, then that still is going to be a less than there. So the same thing holds in subtraction. So if you know that x is compared to y somehow, then it will also be true that when you take some number that we'll just call z again, how about, and you subtract z from both sides, that inequality is still going to hold. So, you know, if it was a greater than or equal to begin with, then the greater than or equal to comparison would still be true between the two different quantities. And you can see that through examples. So like, you know that 6 is greater than or equal to 6, right? So if you were to subtract something from both sides, so if I subtracted, let's say, 7 from both sides, your resultant inequality would be -1 is greater than or equal to -1, and that's still going to be true, of course. Okay, a little bit of interestingness happens with multiplying and dividing, nothing too crazy though. So if we take some sort of an inequality that we know to be true, so I don't know, let's say like 8 is less than or equal to 20. So if I were to take that and I were to multiply both sides by some number, so I don't know, multiply by 2, then what you're going to get is you're going to get a result of 16 is less than or equal to 40, which that is still true. And the same thing would be true if you were to also divide. So I don't know, if you divided both sides by, well, if we pick 4, then your resulting inequality would be 2 is less than or equal to 5, and that still there is also true. So it turns out, right, like when you multiply both sides, you divide both sides, you end up with true statements. But that doesn't always hold when you do things like the following. So if I take the inequality that we've got right here, and then let's say we're going to multiply by -3, how about? Then what we get as a result is that -24 is less than or equal to -60, but that right there is false. -24 is not smaller than -60 if you think about it, because -60 is down here and -24 is up there. -60 is smaller, but that's not what this statement is saying. That's a wrong statement. So it turns out that when you multiply by a number that is negative, and the same thing would be true if you divided by a negative. So if you had the same comparison, and then we divided by, let's say, -2, then you'd end up with -4 is less than or equal to -10, but that right there is also false, because -10 is actually smaller than -4. So when you're multiplying or dividing by negatives, the direction of your inequality needs to change for the statement to become true. So kind of algebraically, what that ultimately means is if we do have x compared to some y, and we know that that is true, then with a positive number z, so with z being greater than 0, then yes, it will hold that x multiplied by z, so times by z, and y that is times by z, that comparison is still going to hold, and also x that is divided by z and y that is divided by z will also hold with the same comparison. So if you had a greater than, then that should still be a greater than, and that should still be a greater than. So let's try to get that all in the same box right there. Move that guy back over. Okay. So, yeah, that's what the multiplication division property of equality says if we're multiplying or dividing by some number that is positive, as you're seeing there. But otherwise, if we do have some comparison between x and y, and that is with some negative number that we now use, so if z is less than 0, then when we compare x to y again, where we multiply by that z on both sides, or we divide by that z on both sides, but now it's negative, then these here are going to have to switch directions now. So if this originally was a less than or equal to, then these are going to have to become greater than or equal to. So it's going to be really relevant for us as we take a look at solving inequalities next.